Hey everyone, welcome back to Papa's Workshop. Why is it when you're making a CNC joint, it always comes out perfect on the YouTube videos? Nobody ever shows you exactly what it takes to make those joints fit perfectly. Today, that's exactly what I'm going to do. I'm going to take just a simple little scrap pieces of wood like this, cut them, and make it where they will fit perfectly together. It's not that hard to be able to do. This is a great little test piece, and if you'll do this, you'll have perfect fitting joints every time. I've opened up the OpenBuild software, and I'm going to connect it to the FoxAlien XC Pro. Now I get this alarm. To unlock the alarm, that is normal. So I do this, and then I go through the homing cycle. When I hit the homing cycle, it's going to actually go through and bring it down to the bottom left-hand corner of the machine. The software that I'm using is the OpenBuild software, which is a free software that works fantastic. I'm not sponsored by them, but I highly recommend this software. And it'll bring it right to this point right there. And I have that little mark indicating exactly where it goes. From here, I want to move it out of the way because I'm going to add an auxiliary wasteboard. By moving the gantry out of the way, this gives me plenty of room to be able to add the auxiliary wasteboard to the original wasteboard. Now this particular wasteboard I use on not only the FoxAlien XC Pro, but I also use this on the FoxAlien Vasco. And I simply align it with the threaded inserts and screw it in position. For my bottom left-hand corner, I use a different type of bolt. This is a flathead bolt that actually countersinks into the wasteboard itself. That ensures that that bit is not going to interfere with my hold-down method for this. And then I'll repeat this same process on the back of the wasteboard as well. I've chosen to use an auxiliary wasteboard because I'm going to be cutting all the way through this plywood, and I do not want to damage the original wasteboard that I have on the machine. And this piece I can use over and over on both of the machines, and when it gets to the point where it's no longer serviceable, I can just toss it in the trash can and make another one. Now to do this simple test today for this CNC joint, I'm going to be using this 1/4-inch upcut bit to be able to do that. Now granted, normally if I'm doing a finished piece of work, I would either use a compression bit or use a downcut bit to be able to make a really nice clean edge. But I think this will work just fine for this simple test. To begin the test, you need to have an idea of the thickness of the plywood. Now this plywood says that it's a 1/2 inch thick, but the best way to tell for sure is to use the calipers. On this wood, it's about 12.09 of a millimeter. And that would be tight. I also can tell you this too. The different plywood, even though it's rated exactly the same thickness, is not the same thickness. So it's a good idea anytime you're going to do a project to be able to do the test with the plywood that you're going to be using. And that will give you the most accurate reading. But for this today, I set it up in the computer. For the piece of plywood that I have was 12.27 millimeters. So that may be just a little bit loose. And if it is, that's okay, because that will give me the reason to do the next step to show you how to make the adjustment to be able to get this perfect. It's time to add the 1/4-inch upcut bit to the machine. And guys, I love this dust boot. This bottom part just snaps off because it's held on by the magnets, and this gives me complete access to being able to change the bits. I've talked about this before, but I have a dedicated 1/4-inch collet that's set up with this so that I don't have to pop this in and out every time. So for my 1/4-inch bits, I grab this setup. Here's the 1/8-inch collet that I have that I just took off with the spindle. So these are the only two sizes that I use, either the 1/8-inch or the 1/4-inch size shank. Now there's other different bits available with different size shanks, and if that was the case, if you're using those, you can do this same exact setup with whatever size bits that you have. Just buy the appropriate collet and set it up into the nut, and you're ready to go. Now once the bit is changed, you can easily go ahead and replace the bottom portion of the dust boot as I'm doing here. But keep in mind, it's actually easier to go ahead and do the probe on the project before you connect this. Either way, it just snaps on and off very easily with these two magnets on each side. I'm using the glue and the tape method to be able to secure this project board to the Wasteboard. Now, I've shown this many times before, but surprisingly enough, I still get a lot of questions. But basically, all you have to do is just place the tape onto the Wasteboard, and then to be able to align that second piece of tape, I just use the board itself just to get it aligned up. Then I can move it out of the way, stick the tape, and that gives me the perfect alignment. It's important to note it does not take a lot of the CA glue. Just one little bead along each piece of the tape, and you do not need multiple layers of tape. Now in this case, once that's done, lightly spray it with the accelerator, and that's not all that's necessary. Once you place this down onto the auxiliary Wasteboard right on top of this tape, just press it into position and it will be secure and it's not going anywhere. Now the CA glue that I'm using is the CA glue by Starbond. Now this is the medium thickness, and by the way, I do have a link in the description for a substantial discount should you choose to use this. For me, this method works extremely well, and it actually eliminates the need for the tabs. It's time to get to the computer now, and I'm using the VCAR Pro to be able to set this little simple design up to be able to test this joint. If the first test doesn't work, I have plenty of room to be able to duplicate this and change the size of these slots to be able to make adjustments and another test. You can easily see that I could actually duplicate this 3 more times to be able to have a total of 4 different tests if it was necessary on this small little scrap piece of wood. But the more important thing is, let me show you how I actually created this little simple design to do this test. To begin with, let's create a new file. Now this file is going to be single-sided. It is going to be 12 inches by 5 inches, and this is a 1/2 inch thick. We're going to start out using the inches. The 0 position, of course, is going to be the material surface. And to start with, I'm going to use the center point for the datum position. Everything else will be fine, so we'll just click that, and that will take care of the work area that we're going to be using. To create this simple design, I'm going to come up here to the rectangle tool. We'll select that. I'm going to use the center point as my reference. Use square corners. This will be a 2 inch by 2 inch, and I'll hit create. And that puts the 2 inch square right here in the center, and I'll hit close. Now that I have the 2 inch by 2 inch square, I need to be able to make this notch just be dropping in here. So the easiest way to do that is go back and do the same thing again. I'll leave my center point as a 0. That's okay. That's going to be square. But this time, my x-axis is going to be 1 inch, 1.0, and on the height, we'll just make this at 0.5 of an inch. And then we'll hit create, and there it is. And we'll close that. Now, what I want to do is just slide this over. I'll slide this over just where it crosses over that line. Now, of course, there's many ways to be able to do this. This is just the way that I'm choosing to be able to do this very, very simple design. Now, with this done, let me zoom in here a little bit. I can come over to the scissors tool and just clip this and that, and the design is complete. Just that simple. So we'll close this. Now at this point, I can click this, and you can see that all of my vectors are closed, and I'm actually ready to design the tool paths for this. So I'm going to take this, and we'll just slide it down here and just get it out of the way. Because what I want to do is come back over here and show you something else. I can come back up to the actual job setup and change this to the millimeters. And you notice everything changes to the millimeters at this point. So I'm going to click OK, and I'm going to come back to my rectangle, and we're going to do the same exact thing, but this time we're going to set this up for the millimeters and create the same box. So we know that 1 inch is 25.4. So I know that I'm going to need 50.8 millimeters to be able to get my 2 inches. and the height will be the same thing. And that will create my box that I need, just like I did before. So now we'll close that. We need to do the same thing now to be able to create this slot. Just as I did before, I'm going to select the rectangle. We're going to come down here, and I'm going to put in on the x-axis 25.4. And for the height, I had said earlier in the video, I was going to use 12.27 millimeters to be able to create that slot. So there's a slot created. We'll close this out now, and we'll do the same thing as I did before. I'll just take and slide this over, just like that. I want it to be just barely over. And let's zoom in so that you can see that. And now I'll just take the scissors, and that will be my cut tool, clip that away. And again, so we have the inches and we have the metric. Now basically they're identical. The only variation is going to be in the first one we used a 1/2 inch for the slot, and for the second one I used 12.27 millimeters. So at this point, let me take this one, let's move it right down here. Let's go over now and create some tool paths. So we're going to click this little icon right up here that says switch to the toolpath command. Now under the setup, I want to be able to look at this, and we're going to change a couple things. One, we have the thickness at 12.7, that is fine. But right here, I want to change this to the bottom left-hand corner, which we can do very easily. And you'll see that start point down here. And this is fine. Everything else is going to be okay. So I'll click OK down here at the bottom. And now we're going to go to the toolpath operation. Under the profile toolpath, I have a start depth of 0, which is on the surface, and then we're going to cut down 13 millimeters. I want to cut all the way through this material just a little bit. Yes, I could put in 12.27, and that would be fine. But we're going to go with 13 millimeters, just a little bit deeper, to make sure that we cut all the way through the material. As I had said earlier, I'm using a 1/4 inch end mill to be able to do the cutout. And I'm going to set this up not at 7 passes. Don't need to do that. We can come over here and edit the passes. I think 3 will be just fine. So we'll hit OK. We are going to cut this on the outside. And it's your choice if you use tabs or not. Just to be able to show you the tabs, I can add tabs just by clicking this. Then I can edit the tabs. Of course, there's no vector set. So let's set the vectors real quick. So that's highlighted. If you want to edit tabs and put those in, you can just click here, and you can see how this little icon changes. You see the check mark? When that check mark is there, that means it snaps to that point, and you can add a tab. So if I want to put a tab here, I can. If I want to put a tab down there, that would be how I would do it if I was going to use tabs. But since I'm using the glue and the tape method, I'm going to delete all the tabs, hit close, and I want to make sure that that is not checked. As far as the ramping, I like to add the ramps in there. I like to use the angle. 20 degree works real well. And at this point, I can calculate. And yes, this will cut all the way through the material. That warning message is expected. So at this point, when you hit calculate, you're going to see the different tool paths. And that looks great. Let's go ahead and hit reset and preview all the tool paths. And at this point, you'll see what it actually looks like cut out. Now you'll notice there's a slight difference between the two. The reason, the first one was set at 0.5 and the second one was at 12.27 millimeters. Very slight difference. To actually do the carving, I set this at 12.27 millimeters for both of them. Okay, I went ahead and set up the XY home position at the bottom left-hand corner. I have my dust boot on where I want it, and it's about a 1/2 inch above the bottom edge of the bit. But remember, we're cutting all the way through this material, and that way when it gets near the end, these bristles will be actually touching the surface of the wood. Now the next thing I want to do is go ahead and do the Z probe. So I'm going to move over just 1 inch And I can set this up. In fact, we can take this off. And we'll do the Z probe. So now the probe is complete. So we'll remove it, get it out of the way. Replace the dust boot on just like that. And that just snaps right in position. Once you get it aligned, there we go. Now let's attach the hose. And we're ready to be able to load the file. In the USB E drive, which is my little thumb drive over here, this is where I'm keeping all the files. Now because this is a little test, I didn't set it up in its own little file yet. But this is my test file right here, so I'm just going to click on it, and that will load that into my Open Build controller software. And there you'll see the file pop up. This is what it's going to carve. And all I need to do now is just hit Run Job. And we'll just click on this button right here. Now, in addition to the test that we're doing today, we're also testing out this vacuum system over here. I'm setting it up so that we can actually get a good test using a 1/4 inch bit this time to be able to generate a whole lot of sawdust. I think it's going to be a lot of fun just to see how effective this unit is and how much of the dust remains on the CNC machine. Right now we've cut about halfway through this material and there is virtually no sawdust anywhere to be found on this machine. This dust boot and vacuum system is doing an amazing job. Because I'm carving all the way to the very edge of this material and that dust boot is actually hanging over, I expected a lot more sawdust to be on this work surface, and it's not. So quite frankly, this proves to me that this is a very, very effective dust boot and vacuum system. It's literally collecting probably 99% of all of the sawdust, and that is just amazing. Well, the carving is completed. I've removed them from the wasteboard. A little bit of cleanup is going to be required. I'll remove this tape and let's give it a test fit and let's see how it fits together. When you slide these two together, the fit actually is perfect. I don't need to do any adjustment. It's a nice, solid, tight fit. So that's really quite amazing. So even though this test turned out perfect, I still want to show you exactly the steps necessary to be able to make adjustments should you need to. Now once you have the carving completed, it's time to be able to decide how much of a correction that you need to make. If it's too loose, it's real easy. Now you can't use the calipers at this point because there's no way to get the calipers in there, but you can use the feeler gauge. Now this is a real old feeler gauge that I've had for years and it's not in the best shape. But one of the things that you can see on here is it actually is listed, now I don't know if you can see that in the camera or not, but it actually shows thousandths of an inch and it also has the millimeters in thousandths of a millimeter. You can find the appropriate thickness and slip it in here and see exactly how loose it needs to be, and then take the numbers from your feeler gauge and enter that into the computer. Let me show you how to do that. This first method is by far the easiest. What I'm going to do is highlight all of the tool paths. So we're going to get the entire project selected, and then we're going to use the offset allowance to be able to make the change. So with the tool path selected, I'm going to come up to this one. We'll switch over to the toolpath menu, and to make it even easier, I'm going to delete this toolpath that we used, and we'll start from the very beginning. Now this isn't absolutely required, but it makes it easier for this demonstration. So all of this will remain the same. I am going to edit these passes back down from 7 back down to 3. So we'll click OK, and right here, the offset allowance is what you want to be able to enter in. So what you had with the feeler gauge of that distance, that's what you need to put in. If you put in a minus number right here, so for an example, if we put in a minus 0.27, that's actually going to make it larger. So this will cut all the way through. That's the normal message. We'll click OK, and now we'll be able to see the tool paths. So that's what it's going to be carving. So let's reset this and show all of the tool paths. And when you do that, you're going to see where you have that little line there in the center. That's actually widened that material by that 0.27 of an inch. If we put this in now as a positive 0.27, it'll actually make it smaller. So let's reset this, and we'll do the same thing again now, and this time we'll put in the positive number, and that of course is going to make it smaller. So that'll give you a tighter fit. So by doing this, we'll do the same thing again. We'll hit OK, we'll calculate it, and you can see the difference. There's the profiles. We can reset that, and you see that little space is gone, and now that is going to be a much tighter fit by 0.27 of a millimeter. By using the feeler gauge to get the exact amount that you need to use for the correction, you should be able to do this in one step. I want to show you the next method that you can use to be able to do this. And I'm just going to do this on one. The first thing I want to do is come over to the node editing mode. We'll click on that. We'll highlight this, and you'll see all the different nodes. Now, first thing I'm going to do is click on this one, right click it, and I want to cut the vector. Click on this one as well, right click, and cut the vector. Now, what does that do? So at this point, if we highlight this item, you notice that it's now no longer all connected. You have open vectors here. What I want to do is work with this one right here and reduce this, and we can do it by this transform object. And what I want to be able to do is come right down here, and on the y-axis I want to be able to reduce it. Now you notice this is not linked. We want to make sure that this is not linked. The only thing we're going to change is the y-axis. And I want the y-axis to be changed by that 0.27. It can be whatever you find in that feeler gauge. But if I put in the 12.0 and then apply, that will actually reduce this down. And then I can hit close. And let's go back and take a look at this. You'll notice now that it did reduce it on this side, and you can see how it reduced it on this side. These lines are no longer able to be connected. So it's time to rejoin these vectors. So if you come down to here, you can see this little icon, extend the vector to a common point. So I can select this. Well, let's highlight this first. So we're going to select it. I'm going to select the one we want to extend and then select it. And you see it joined it back. Let's look at this one over here. We're going to do the same thing. We want to extend this one and connect it to that. You see it's now joined. So let's close it. Come back to our edit object. Click on this. You can see they're joined, but it still has open vectors. So what do we need to do? We need to make sure that those vectors are closed. Come down to this icon right here, join open vectors. And when you do that, let's highlight everything. You can see that there's two open vectors. We want to join them, and that will take care of it. To be able to prove it, we're going to select it, and you see now everything is joined together, and you've reduced this opening by the 0.27 of an inch. So this gives you an alternative way to be able to change the size. Again, the 0.27 is just for demonstration purposes. You're going to key in the measurement on whatever you had based on the feeler gauge when you took the measurement of the sample piece. Now I pulled the filter out using the 1/4 inch bit, and you can see there's an awful lot more sawdust. It captured just about everything. This did an amazing job to be able to capture all of the sawdust and catch it right here. Now, as before, we have some sawdust inside of here that missed and got outside of that filter. Let's take a look at the second filter now. And yeah, you can see a little bit of the dust that got through into this second filter. You can see it how as I shake it, it comes right out onto the table. And let's look at the third filter now. This third filter with the charcoal filter, you can see it did get a few, very few, but some small particles made it through to the charcoal filter. But as far as on the back side, there is nothing on the back side. So I turned the filter actually inside out and vacuumed it real well and got as much of the sawdust off as I possibly could. And that's not bad. So then once I'm finished, to just turn it back, get it back this way, we'll put it back into the unit. Next test will be to see how it does with the dust separator. Hey, thanks a lot for watching this video today. I hope it actually helped you so that you can see that behind the scenes, people actually do test these joints before they do the actual project. I think it's very important to be able to show exactly how you get those perfect joints on these different projects. And it's something that people really don't show very often. Well, now you know how to be able to do a test to make sure that your joint is going to fit perfectly before you waste a lot of material doing the project and find out that it doesn't fit properly. So if you liked the video, by all means, hit the little subscribe button. You know the routine. Bell notification also. I look forward to the next video with you guys. I'll see you real soon. So bye-bye, everyone.